You're about to listen to the Complete Developer Podcast, the podcast by coders, for coders, about all aspects of life as a developer.
I'm Will, the curmudgeonly experienced developer.
And I'm Beej, the optimistic newbie developer.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
P.U. That code smells. Welcome to another episode. This week, we're talking about code smells, or how to quickly tell what areas of your code need to be refactored. We'll start by defining code smells, then talk about a few of the more obvious or insidious smells you may come across when refactoring your code. But before we get started, Will, what have you been fighting this week?
Well, speaking of open receptacles of code sewage, I've been dealing with WordPress. Yeah, so it started today. Right before lunch, I got an email from a lawyer with a cease and desist warning because one of the websites that I host for a friend got hacked. Mm-hmm. And it wasn't a really bad hack. They just put some crap in there that like is trying to sell purses, and they're, it's like counterfeit goods and whatever.
Yeah. And
so I used part of my lunchtime today trying to get that thing where it would first stop picking that up with Google, like get it out of the sitemap.
Yeah.
Was the main thing, because it's like, that's going to start hitting us on the SEO. The other links are still working at this time, and I've got to take those down after. But I wanted to be at home where I have all my tools, versus trying to do that at work, because, that's not really a good thing to be doing. So that happened. And then, we found out that it was because of the Akismet spam removal plugin. So literally, the site got spam on it because we were trying to keep people from putting spam on it.
Yes.
And WordPress, like, I get all the warnings, security warnings for the sites constantly. Like, those are just always coming in. It's, somebody's been blocked, and, it's this IP address is blocked forever. And yeah. I'm done. I really hate WordPress right now. And I'm at that point, I'm about ready just to roll our own and be done with it.
Yeah, I know. So, we're hating on WordPress more than Microsoft Windows now?
Yeah, seriously. I mean, it's the Windows ME of CMS systems.
Yeah, pretty much.
Like, I've never insulted a platform's mother, but this thing gets me close. Like, what does mother even mean when it's digital? How about you?
Well, I am enjoying some victory beer.
Yeah.
Will and I had a contest to see who would write the first episode to reach 1,000 downloads. And as of yesterday, I have won. So I'm enjoying the beer that he bought me. If you guys follow me on social media, you will see where I posted that a few weeks ago.
Actually, you're enjoying the beer I bought me.
Oh, really?
Yeah. But I got it in advance so that it was ready, and then you won, and I'm like, I gotta just give him the beer. That way I don't have to make another trip to the store.
Well, that's why I've got Dragon's Milk instead of Andy Gator.
That's right.
Okay.
Because you look like you're real upset.
Oh, yeah, I am just, no. On the work front, we're in the home stretch of testing for the app that I wrote when I first started my job. It goes into pilot next week. It's kind of exciting and relieving to be done with it, though I'm sure they'll find some stuff in pilot that we need to work on. That's what it's for. Also, starting next week, I will be on the maintenance team. Up until now, I've only worked on new development, so it'll be kind of different working on legacy code. Some of it's pretty old, and I'm told some of it resembles Rube Goldberg coding. But we've got a good team, so it shouldn't be too terrible. Speaking of Rube Goldberg, though, I got something interesting for IoTs, so let's go ahead and roll the music. This week's IoTs isn't exactly an IoT, but it is a STEM toy for kids. These are the Rube Goldberg STEM toy kits. And they're different kits, or kind of more like board games, to create a Rube Goldberg machine to perform certain tasks. They're designed to teach kind of cause and effect and be a fun game that kids can play. The idea is to set up a machine to ultimately cause a specific response, like sending an acrobat flying through a flaming loop. And by flaming, I mean the flames are painted plastic.
Right.
Yeah. But I'll have a link to some of them in the show notes so you guys can check them out if you've got kids or nieces or nephews. So who's talking to us this week?
Well, we grabbed a email from Marco M. And he says, "You two are great speakers and very informative. While keeping the core of the podcast to what it is, you are successfully covering other topics that revolve around developers' everyday activities. While I discovered your show just recently, I started backtracking your earlier podcasts also, and I can tell you, it's hard. Your mics in 2015 are nowhere near with the quality of your recent shows. Thank God that upgrade happened. Keep up the good work and all the best from Serbia, Europe. If life ever gets you near Serbia, drop a message so we can grab some beer."
Hey, Marco, thanks for the comment. We are constantly working on improving the quality of our content and of the show in general.
Yeah, I listened to an old episode like 6 or 7 weeks ago, and yeah, the cringe factor's there, man.
Well, the thing is, it's not the microphones, because I've known people that did really good shows with those microphones. It was the setup we had, because we were using the desk stands for them.
Yeah.
And we didn't know what we were doing with those microphones.
Well, and we had different music selections, and yeah.
I also was using a completely different tool for editing and mastering, and the new stuff that we've learned has also contributed. But yeah, the microphones do make a huge difference.
Yeah, just the whole setup. I mean, throwing $1,500 at things fixes a lot of it.
There are some things you can fix by throwing money at it. And that was one of them.
And for everything else, there's interns.
Yes. Well. But Marco, I do enjoy traveling. So if I'm ever in Serbia, I'd enjoy getting a beer with you. But in the meantime, send us an email to neckbeards@completedeveloperpodcast.com because we have a Complete Developer water bottle just for you. And guys, if you'd like your very own Complete Developer water bottle, leave us a review in iTunes or comment on the website or any of our social media. We post all our episodes to Facebook, Twitter, LinkedIn, and Google+. We're also on Path and Tumblr. Now, this is the last week to enter to win a copy of Bethany Adams' book. Leave us a review in iTunes to enter. We'll be announcing the winner next week. So this episode came about because I was adding logging to an app that I'm working on at work, and I found that I needed to use try-catch statements to log the errors, and then from there handle the exceptions. I'd heard that try-catch was a code smell, and not understanding what that meant, I assumed that you should never use it. Yeah. So I understand now that by calling something a code smell, what a person is really saying is that when you're going back through your code or refactoring, that means it's something that should jump out at you as look here for potential areas that need refactoring.
Yeah.
Originally coined by Kent Beck, according to Martin Fowler, a code smell is a surface indication that usually corresponds to a deeper problem in the system. They're patterns in code that are quick and easy to spot. Even junior developers and those learning to code can smell bad code. I mean, you don't have to be a 5-star chef to smell that the meat has spoiled.
Yeah.
From a pragmatic standpoint, not all code that smells needs or can be fixed. The idea here is that these are patterns that are easy to identify and show that the code needs to be reviewed when you're refactoring your code. It's like, look here for potential problems.
Right.
And for a gentle introduction to refactoring, check out our episode on the topic. Now, depending on who you ask or where you look, there are a lot of different code smells, from general smells to paradigm-specific to even language and framework-specific smells.
Right. Like you were talking about try-catch as being, somewhat of a code smell or anti-pattern. Mm-hmm. And obviously, like you want structured exception handling, but a lot of times what you see is try with an empty catch. That's real bad.
Yes.
That means, hey, swallow an error and move on.
And I know when I was working on that and I found that that was how I had to do it, I messaged you. I'm like, hey, if I'm handling the exception, do I still need to throw it in the catch?
Right.
Because another thing that we'll be talking about in a future episode with one of your neighbors is when he was talking to us before, he mentioned one of the ways that he, as a pen tester, gets information about an app is through the error messages.
Oh, yeah. Like that's how you can determine if SQL injection work or it will work on it. I mean, you can put somebody's name with a single quote, and if it bombs with a SQL error, then Yeah. You can start hacking right now.
And so I want to hide the API errors from the UI. And so I've handled those errors. It also allows us to fail gracefully.
Yeah. Well, some failures are not failures.
Yeah.
They're temporary failures, or they're transient failures, or they're a normal operating condition and you retry or you do something else.
Like the one I've been using to test my logging framework that I'm using is when you're looking up something with a tracking number, what happens when you put in a number that doesn't exist?
Right. You get a null reference exception, or you get, yeah.
And so now, instead of that bubbling all the way up to the UI, it gets caught at the controller level in the API and handled so that an empty object goes up to the UI and the UI code handles that gracefully.
Oh, you're using a null object pattern.
Yes.
Yeah. Yeah. I like those. It's way better to keep things sane, because most of the time you don't really need.
I didn't realize I was using a null object pattern until you just mentioned it.
Yeah.
It just was the logical thing to do.
Well, it's like, you don't realize you're using a doorway pattern until you got to walk out of a room and you go through a hole that opens up.
That's true.
I mean, like, they're just sort of like, this is how you do stuff.
Yeah.
And we had that discussion in the design patterns thing. So I guess,
depending on where you look, code smells are categorized in different ways.
Yeah.
And we're going to be grouping them by what they do or the problems they cause.
Yeah. And this is not anywhere near an exhaustive list, because honestly, if you get any developer who's been at this for a few years, get them a couple of beers and sit down with them, you're going to find out that basically they can go for hours.
Oh, yeah. That's what I said. The ones we're going to talk about are kind of general and specific to object-oriented code. But for each smell that we talk about, we'll talk about what it indicates, why that can be a problem, and kind of some general ways to handle it without getting into the specifics of the code.
Yeah. So the first pattern, or the first, what do we call it? The first bucket of slop here.
Well, the first group of patterns.
Yeah. Is the change this at your own peril type of problems.
And if you have to change something in one place in the code, it has to be changed in multiple other places, or, either within the class or in the code in general.
Yeah, and I actually have a service I'm working on right now that exhibits this, like where they should have, it literally pulls stuff out of a database and says, hey, I'm going to send an email. It sends the email and it puts that back in the database, right? You think you could do that in 500 lines of code? They used 15,000.
Wow. Well, I'll be honest, when I was writing this, I was thinking of your ASCII, there be dragons here.
Yeah. That was a different case.
But that's what I was thinking when I wrote this. I'm like, that is what was going through my mind. Now, these smells can lead to complications in refactoring and iterative design. Your Scrum and your Agile have issues with when you make changes based on new stories coming from your product owners. If you have to change it in multiple places, this becomes a problem.
Yeah, well, you get several different effects. The first one is you have like a divergent change where it's like, I'm going to change, we got 3 or 4 vertical, like in the app, the service I deal with. Yeah. There's 4 vertical slices that are like code paths through the thing, even though it should be one with like, if statements, because we do computing. But instead we have 4, right? Because somebody just said, we'll put the if at the top, and then everything can just be copied and pasted. That's wonderful. And so like you'll have one case where it's like, hey, we're sending out using MailChimp over here with not HTML emails, and we need to fix that one thing, and it gets fixed. But nobody knows, somebody doesn't know that those other slices are there. And so all of them are busted in that one use case.
So a divergent change is something where if you change one part of a class, you have to change it in multiple areas within that same class.
Yeah. You have to change it, but you probably don't.
Yeah, exactly.
That's like, and have to is like the pirate code.
Yeah. This tends to be just a sign of poor architecture.
Yes.
And it's more likely to occur to you earlier in your career. Not that you're likely to see it earlier, it's just that you're likely to do this earlier in your career.
Yeah, well, your event horizon for like planning is closer.
Yeah, exactly. And experience should provide better architectural design. And I know where Will's going to go with this, because he's going to say all the different senior developers he knows that doesn't do this.
Yeah. I mean, it should, right?
Yeah.
But it's sort of like, there's always that one kid that touches the electric fence twice. And some of those kids grow up to be senior developers. Mm-hmm. So that's that.
to fix this, extract out the parts that are changing and put them into another class. This reduces duplication and increases your organization and helps to maintain the single responsibility principle.
Right. And again, that also makes it where two members of your dev team can fix things at the same time in two divergent classes. Mm-hmm. So you get more throughput that way.
Next is what I dubbed the MASH effect. And that's MASH as in the TV show. But actually, it's called shotgun surgery. This is where changes in one class require multiple changes in other areas. So if you change something here, you have to go change it in all these other places. It's kind of the opposite of the divergent change, where it's all within the same class. This is, you change something in one class, and then you have to change like 5 more.
Yeah, instead of copying and pasting within a class, they copy and paste within a module.
Yes, exactly.
That's basically what that is. And we have that too. Yeah.
And this can come out of overuse of the single responsibility principle.
Yeah.
The responsibility is broken up into several classes. So one responsibility across multiple classes. As I stated, it's the opposite of the divergent change, and it can result from overfixing it.
Yeah, or you try to use a new cool pattern for it. And typically what happens with that is people get about 85%, and then they get hit with a deadline, and then that's there forever. And that's how you get this. It's actually an incomplete thing more than it is a overcomplete, if that makes sense.
Oh, I got you.
But it looks like they overdid it because you didn't get the whole picture didn't come in.
Well, what I've seen through research is that, and also that someone was coming in and refactoring and goes, oh, I need to break up this single responsibilities, and they over break it up. They go too far into that.
Yeah.
So, I mean, it can come from either side of that.
Yeah, agreed.
And what you need to do here is to bring the classes together into a single class for each responsibility.
Yeah. And I think the other thing, too, is like how you slice your responsibilities. That's something you should develop as a skill.
Yeah.
And a lot of people develop that in a very questionable manner that doesn't seem to take into account difficulty of maintenance or the impact on the project schedule.
Mm-hmm.
And so,
exactly.
Yeah.
And finally, under change this at your own peril, is parallel inheritance hierarchies. Anytime you create a subclass of one class, you have to make one of another.
Oh, yeah. We used to have this problem in C# way back in the day when we didn't have generics. Mm-hmm. And so you would say, okay, I'm making an animal class, right? And I've got to make an animal list that is like inherited from array list and is strongly typed. And I did all the crap that you have to do for that, which you never have to do now. And then you go, oh, well, I'm going to make a cat class and a dog class. Oh, well, I've got to make strongly typed collections for these, strongly typed iterators for these.
Wow.
And so you get this explosion of stuff, partially because of language constructs, but also partially because the pattern that you're accessing it in requires you to define all this other stuff.
Okay.
So it's very easy to do.
This is not a big problem with smaller hierarchies, but as classes get added, it becomes a nightmare. Yeah.
And this is actually why a lot of times I'm very reticent to jump in and add a base class for something. Mm-hmm. Is because that's how it starts. Like, it's sort of like Anakin turning to the dark side. Yeah. This is killing sand people. It's not, it's not like wiping out the Jedi Academy. This is how it starts, and it all goes bad from there.
I do want to point out that not all smells indicate the worst code.
Yes.
This could be a way around something even worse. And if by fixing this, you make the code worse.
Yeah, you didn't win.
Yeah. Go back to the parallel hierarchies. To get rid of this, you can remove the duplication by combining the hierarchies.
Yeah, that can be more or less tricky depending on, what your environment is. But a lot of times that is a good way around. The other thing that you can do as well is flattening the hierarchies.
Yeah, that's true too.
So, decrease the total area or total volume of your hierarchy, and you're probably better off.
Mm-hmm. Next, we have the group that is over-adherence to a paradigm. And for this, we're going to talk specifically about object-oriented abusers, or Java circa 2010.
Or .NET circa any time now.
This could be incomplete application of a paradigm, overuse of the paradigm, or incorrect or inappropriate use of that paradigm. So the first one here is similar classes with different interfaces. 2 or more classes that do the same thing but have different interfaces or method names.
Yeah, and this is the bane of my existence right now, actually, in one of the projects I've got to deal with, because legitimately you see the same code copied into 2 different methods that are named slightly differently. Mm-hmm. And they're not, like, the classes are completely divergent, but they have a lot of the same code.
Yeah.
Slightly different method names and a few different calls. It's just like they literally copied and pasted and said, oh, I need to call that this over here. And that's atrocious.
So this really boils down to another code smell, but it's duplicating functionality within the code.
Yeah.
And usually happens when developers refactor not knowing what one class does, or when you have different people working on the code at different times.
Or somebody not completing a refactoring.
Yeah.
You know, again, that strangely seems like that's the biggest problem I run across. Like, the longer I go, the more that leads back to nasty.
I can totally see that, to where, just having been in the workforce the time I have in development, I can see where you've got a couple of weeks to do something and you get done early. So you're like, all right, I'm going to go back and refactor this. And it ends up taking longer. And then you hit your next sprint or your next deadline starts coming up. You're like, all right, well, I can't keep doing this because I got to go.
Yeah.
And they didn't think to do the appropriate thing, which is create a feature branch to do the refactoring in.
Right. Yeah.
And we're going to talk about that in a little bit anyways. But this can also result from too many cooks in the kitchen.
When everybody's touching part of a system.
Yeah.
And, you know, you'll end up with, like, I like to call them bread heel classes. Mm-hmm. You know, like the heel of a loaf of bread. Like, everybody touches it, but nobody wants it.
Yeah.
Like, you'll have a few of those floating around in there, and everybody just touches it just enough to make it dirty.
Yeah, I know what you mean. Yeah.
And there's probably a real term for that, but I like my term.
I like bread heel classes. I'm going to use that from now on. Yeah. I'm going to make that a thing if it's not already. But what you want to do here is to put those interfaces into common terms between the classes. That way they can share an interface or
they can share an interface, or they can share a base class, or somewhere in a tree type hierarchy.
Or you can make one class a subclass of the other.
Yeah.
Next is the refused bequest. This is when you inherit from a class but don't use anything from the parent class.
Oh yeah, I love this pattern. And this one's my favorite, where somebody's put a constraint that's too tight on something, and it doesn't really need it. And so you just stub it, or they made the interface too big. So it's like it takes an instance of this class, like Microsoft's membership libraries back about ASP.NET 2.0. It's like, I'm going to implement a member class, right, for like a user in my system. Okay, well, how many properties do I have to have? Well, there's like 36 of them. And how many of those do I need? 3. So you had to implement all of those and like extend this thing. And it's like, I don't need this. What is this? We're going to
talk about that. That's its own smell. And we're going to talk about that in a little bit too. But within these subclasses or child classes, you may only use some of the methods or properties from the parent class. And the unnecessary methods are either unused or they may be redefined, meaning that exceptions have to be handled.
Yeah. Or they're defined and they throw something that indicates that they're not even implemented.
Yeah, that's true.
Which is also a common pattern. That's so much fun when you have complex object hierarchies and you're like, yeah, it goes through 1,000 records and it just detonates. What happened?
Yeah. And this comes about through overuse of inheritance to reuse code, but the classes are just too different. Inheritance used only to combine common code, not because a child class is an extension of the parent, is a problem.
And I can give you an analogy that's probably appropriate here. Do you know what you get when you cross a giant squid with a rhinoceros?
Squidoceros?
You get a visit from the ethics committee and a cessation of funding, actually.
Okay.
Now, what do? We combine two things that ain't the same thing.
Well, I was going to say the example I found in reading about it online was a dog and a stool both have 4 legs, but that's about it.
Yeah.
What you want to do here is...
So they both implement I has 4 legs.
Yeah.
In Java parlance. Which means you could use an I has 4 legs factory to create the factory to create them.
Exactly. So what you want to do here is replace the inheritance with delegation. Put the parent class object into a field, then delegate the methods used from that parent.
Yes. Actually, building stuff by composition is a really nice way to get around a lot of these.
Yeah, that's true. If you must inherit, take the methods that are used by both and make them siblings.
Okay.
Think about
So
it.
like make a
new parent and make them both siblings of that parent to inherit the methods that they're both using.
That way you don't break either one's implementation and you keep them separated because you're not entirely sure.
Yes.
Because you probably aren't as sure as you think you are.
Yeah, exactly. And now comes to one that you kind of hinted at earlier, and that is cherry picking with temporary fields.
Yes. And adding, like you want your class that you're using to have everything it needs. But what you don't want to do is say inherit that or inherit an interface that has a bunch of crap you don't need because it needs to fit into this other mold. You have to be capable of reworking an object hierarchy and moving pieces back and forth. That's why a lot of your refactoring tools are like, move method up, move method down.
Yes.
So that you can do this quickly and not break things. This is definitely one of the things that's a significant pain point. Anytime when you run into it, you'll know what I'm talking about.
Mm-hmm.
That's, and a lot of it is, when stuff is needed only under, very specific circumstances, or when somebody abstracted something in a way that made sense at the time, but doesn't make sense with like emerging business rules. I'll give you an example. At work, we have a system that if you have a document that goes through, that's what a payment is attached to, right? Because it used to be, hey, you printed a document, you got to pay for it.
Yeah, that makes sense.
Right? Well, what happens when you build out a full-on payment system? And somebody goes, well, that's attached to a document. Well, it's not attached to a document. It's attached to a bill, which is different.
Mm-hmm.
But there's still got to be a document.
Yeah.
Because database constraints, object constraints, like all up this chain is the stuff, and you got to fake it all the way up. And we're still untangling that one.
A lot of times you'll also see this when an algorithm has too many inputs.
Yes.
And so instead of sending a bunch of parameters, they are added as fields in the class.
Right.
And the data in those fields is empty most of the time.
Yeah. I think part of the deal there, too, is understanding the difference between a class that's a data that's like a bucket of data that you're acting on like an entity versus a message.
Yeah.
And when you tease that apart, like all of a sudden all these just like start sticking out in the code with sore thumbs.
Oh, yeah. Speaking of that, to get around this, pull out the fields that are temporary and put them into a separate class.
Yeah.
And use that when calling the algorithm. This creates better clarity and organization in your code as well. Hey guys, I just want to take a break real quick to invite y'all to join us June 1st through 3rd for Music City Code, Nashville's hometown tech conference. Music City Code is packed with workshops, seminars, and panel discussions to inspire progress in Nashville's tech community. Music City Code will be held at Vanderbilt's Surratt Student Center Thursday, June 1st through Saturday, June 3rd. Ticket prices are half off through May 1st, and if you refer a sponsor, you'll get a free ticket. To learn more about Music City Code and register for the conference, visit musiccitycode.com. The next group of code smells is poor relationship boundaries.
And Beej is looking forward to this one because his inner psychologist has realized that class hierarchies interact badly in the same way people do.
This is what happens when coupling is taken to the extreme. Or decoupling is taken to the extreme. Either way.
I suggested some coupling options to the WordPress team earlier, actually.
This is what you get when you have excessive or too tight a coupling, or when you get not tight enough coupling or excessive decoupling. Now, I want to point out that we did not name these smells, but they definitely had a sense of humor in the naming.
Where do the names come from originally on this one?
See, I found they were the same names across like 4 or 5 different blogs. I'm thinking they come from Martin Fowler.
Oh, yeah. That's probably the case, actually. I may have his book back here.
Yeah. The very first one is Inappropriate Intimacy. Oh, my. In my best George Takei
impersonation.
Which is terrible, but you know.
Yeah. Thank goodness it's terrible. Be a little worried about you if it was a really good one.
Well, he's got a good deep voice. But this occurs when one class uses the internal fields and methods of another class. It happens when classes spend too much time together.
Yeah. Well, it's a lack of enforcement of boundaries of what something does. And the best way I can, to put this in human terms, let's say that you're a boss and you have a secretary. And your secretary knows that you do certain things in a certain order. So like if these papers are right here on the desk, they're for this thing. And if they're over here, they're for this thing, right? Mm-hmm. Well, if the secretary just blindly goes in and goes, oh, I'll just grab this stack of papers and walks off. If you ever change your desk layout, you are screwed. That's what that is in a programming capacity.
Not where I thought you were going with that when you mentioned boss and secretary. But yes, I agree.
I like to build up the tension. People are sitting there going, do I have to turn this off before my kids hear stuff?
So your classes should only know what is necessary about one another.
Right.
And there's several solutions to this depending on the situation. The simplest is to move parts from one class to another.
Yeah. If the secretary needs to know about that pile of papers, maybe it should be on her desk.
Yeah, exactly. The other is to create a relationship hierarchy or inheritance.
In other words, an inbox and an outbox.
Yes. And if they are interdependent, change the dependency to unidirectional.
Which is like screening calls.
Yes.
Yeah. Or telling the secretary, here's the stuff to do, not don't take it off my desk. Like, I'll tell you, I'm in control.
Yeah. So the next one is indecent exposure.
Yes. And the best way to put that is your parts are showing. And that occurs when methods or classes that should not be public are visible. Parts that do not interface with the public are shown. And that's like getting into really important code that's, kind of critical and being able to diddle with it, basically.
Yeah.
A really good example of this is security-related classes. Like if you have something that goes, okay, I'm going to encrypt, this data in some way, right? Well, you might have an encryption key loaded up in the class. Now, you ought to also be protecting that in memory, and there's all kinds of stuff around that. But let's say that you're just doing it as a string because it's an initial implementation, and you make that a public field. So now somebody can say, hey, I can read this class publicly, like any assembly in the app domain could go out and find this thing, find an instance, and get that. Like, that's real bad. Mm-hmm. It's even worse when they can write to it.
See, I was thinking about what I talked about earlier with the logging stuff and the error handling, where showing those errors to the public on the front end was indecent exposure.
Yeah.
We shouldn't be exposing the errors to John Q. Public out there. Anyone that logs in can see these errors.
Yeah, well, I'll give you another one. Like, let's say you've written your custom logging framework, right? Let's say that I go logger.log, here's some stuff, bro. And you return with a SQL error. Well, do I care? Like, I get it that you go, okay, I can't write to this data store. I can't write this message. But don't tell me it was a SQL error. I don't care. Right? Like, that's inappropriate. That's exposing stuff that's like your internal to your implementation to me, that I'm using it. And that's not... Does that make sense?
Yes and no, because I actually exposed the internal exceptions to the logger because I wanted to see those.
Yes. You want to you're delegating to the logger, right? You're saying, here's an error, put this in the thing.
Yeah.
But the logger doesn't need to say, oh, I was trying to write this to the database and here's a database exception. And you say, hey, there's a logging exception.
Totally get what you're saying. I agree 100% with you. Yes. Yeah. This basically happens when code is not hidden or improperly hidden.
Yeah. And incidentally, if you're in .NET and you're using a private string field, it's improperly hidden if you're doing secrets and any kind of encryption type stuff, because you can reflect and still get that. But that's more of not a class design, but hey, you're getting nailed by security type thing.
But basically, you need to make private methods private. And when you can't do that, encapsulate them. Yeah. This reduces the complexity of the code and protects methods that should be private.
Yeah. And, for our British audience, that's the difference between saying, I'm going to the loo and giving them an exhaustive rundown of what you're going to do at the loo.
Speaking of the loo, the very next one is feature envy. I think I broke Will.
I did not mean to line up that transition like that. Okay.
And this is what happens when a method uses another class more than its own. Access to the other object's data more than its own object's data, or it relies on the other class way too much.
And, a lot of times it's specific implementation of another class.
Yes.
Right? Because like you do interface calls, you can get away with a little bit more. But that tends to be that tends to show enough coupling that's like, hey, I ought to move some of these over here instead of them being over there. And it's not typically as much with data as it is, hey, I'm going to call method on this thing. So I'm going to spin up one of these classes and then bombard it with all these method calls when it's like I should just have it internal. Now, if that class is inside of your current class, that's also the composition method that we talked about earlier. So this is one of those that's a little fuzzy, but you definitely need to look at it.
Mm-hmm. This typically occurs after fields are moved into a data class.
Yes.
Things change at the same time, and when data is moved, the functions on that data should be moved.
Yes.
But they're not always moved.
Yeah, they're not typically moved because people are lazy.
That's really
Let's
true.
be honest here.
The trick to this is just move the method to the class it uses most. And if only part of the method uses it, extract that part out and move it.
Yeah, and sometimes you may even have to do stuff like putting callbacks in.
Yeah.
Right, like where you pass a delegate or something to that class. Like there's a piece that's in yours and then all the rest of it's in this other thing. You may have to make just pitch a function along and go, okay, here's how you interact with that one little slice.
Yeah, exactly. This reduces redundancy and helps to organize your code better. Next are message chains. These are long sequences of method calls to get the data. You request an object that requests another object that requests another object, and on and on and on. And
the best place in the world to find this is where people are using an active record pattern or entity framework or something like that poorly, and they don't understand how to use stored procedures or how to deep load or those kind of things. And so what they do is they go, okay, let me get the top of this entity hierarchy, and then I get the children, and then I loop through those, and I get their children.
Yes, exactly, yeah.
And, oh, man, that's...
This basically means there's a dependency on navigation through the class structure, and any changes require modification of the entire chain.
Yeah. And I guess it's probably useful to mention at this point that it's not just about your dependencies on other classes that make things smell. It's like if you are dependent on how two classes relate to each other, that's also a code smell. It's any subset of the graph or any subset of the, it is a graph. If you're dependent on any subset of the object graph, whether it is a individual class or a set of classes, you're probably in a bad spot.
And on that same note, you need to watch out for intermediaries, as a lot of temporary variables can be the same thing and tend to hide these dependencies.
Yes.
To get around this, create a method in the first class to delegate to subsequent classes. This hides the delegation from the code calling the method, makes it easier to make changes to the program, and reduces the risks, but you do need to watch out for overdoing it and creating unnecessary go-betweens, which lead us into the next smell, which is middleman. This is when a class delegates all its work.
So it's like a proxy.
Yeah. It's only one function that is delegated, or all the functions are delegated. So either the class has one functionality and it delegates that, or everything it does is delegated.
Yeah.
Basically, it becomes a wrapper for other classes.
Yeah. Now, there are a few places where these are not necessarily bad and you'll run into them, like controller classes.
Yeah.
On the web, right? Those should be delegating. You shouldn't be doing the business logic probably in there. You should be pitching it on in to something else. There's a few spots where that kind of stuff happens.
Well, a controller class...
its purpose is to route.
Yeah. Its logic is guiding those.
Yes.
So it's controlling where things are going.
Yeah. Whereas if you go, okay, now the next step down is I'm going to have a repository class, and the repository class then delegates to something else to actually go get the stuff.
Yeah, no, that's
that's kind of bad. It's a thing of understanding that the class should be descriptive of what it's doing. If it's a controller, it should be routing requests.
Yeah, that makes sense.
It shouldn't have, I'm going to spin up this other thing that actually does the routing.
Yeah.
It's like there's a controller base, and then there's real controller base.
This happens a lot when the useful work done by a class has been moved to other classes, and can also result from overuse of fixing message chains.
Yes. The other place it'll get you is when you have a public entry point into a chunk of code, like a DLL, and everybody's used to calling this one class to do stuff, and you moved all that functionality. Well, now it's an endpoint.
Yeah.
You can't fix that until you do a breaking change, but you got to pass all that stuff through. So do be aware of that, just because, like, if you use a code refactoring tool, it says, oh, am I using this anywhere? No, I'll just pull it out. Yeah, don't do that. If it's public, be careful. Ask me how I know about that. Be careful of any of these, really, if you're in a situation where something is public and other people are using it, because yes, you may be able to move pieces around, but if other people are calling it and you don't have control over them, that's a bad place to be, because you can actually cause a breaking change that way. So you have to be cautious, I guess, is more than anything. Mm-hmm. If it's not public, though, refactor away.
Yeah, basically remove the middleman.
Yeah.
The final smell under poor relationship boundaries is the incomplete library class. And this comes in several forms. This could be where you need a method that is missing from the library, or the library stops meeting the needs of the code where it once did, or the responsibilities of the code should be in a library. This becomes a problem when you're unable or unwilling to modify the library class, either because the author of the library doesn't provide it or refuses to add new features, and methods tend to get tacked on to other classes. If you don't have access to the library class, you can add a method to a class that then passes an object of the library to it.
Right. You can use basically a mediator type pattern to talk to the library, which is what I like to do for external libraries anyway. Like anytime I call the Windows API, I have a class that's just like a bucket of here's where we connect. Mm-hmm. Because I don't want that stuff anywhere else. Because when that stuff goes wrong,
it to that one spot so it doesn't break everything else.
Yeah, or when you get a GDI plus error, then you get unspecified GDI plus error when you're doing graphics programming, and that's the answer you get. Like, you really want all that in one file.
Yeah, exactly.
Because you can just set breakpoints everywhere and then maybe find it if you're lucky.
Yeah. And you can also create a new class with extension methods that are either child or wrapper methods for the library.
Yeah, if you've got a framework that lets you do that. And depending on what you're doing, like C# has got straight up extension methods. JavaScript you can actually add to the function prototype, which is really nice. There's some other languages, not so much, but they tend to have other ways around this because everybody has this problem.
Well, that pretty much wraps up the first half of the code smells we're going to discuss. We originally recorded this as one long episode, but realized afterwards while editing that to keep all the relevant information, we should split it into two. Also, I really didn't want to render an 1.5-hour episode on the crap top.
Yeah, because that would take, like 4 hours or something.
Yeah, exactly. We've been talking about individual smells and what they can indicate, but I do want to point out that just because code smells doesn't mean that it needs to be refactored or changed. These are places in your code that are most likely to contain areas that need to be refactored. Yeah. Not everything that smells is rotten. Very rarely, you just might find some well-aged cheese.
I was going to compare kimchi and rotten cabbage, but okay.
Well, there's that too. This week, we've discussed code smells related to class structure and the architecture of your code. Many of these smells indicate mistakes that developers are more likely to make earlier in their careers, though more advanced developers may be responsible for them too. Check out next week's episode for part 2 of Code Smells, where we'll discuss smells related to the actual code itself with naming, unnecessary, and bloated code. Before we close everything out, Will, what do you have for us this week for Tricks of the Trade?
Well, since this week's episode was about code smells, I'd like to point out that the root causes of code smells are pretty similar to the root causes for being ineffective and disorganized in general. Having stuff in the wrong place, not having stuff in the right place, trying to use things for purposes for which they're not intended, etc. It can be really instructive sometimes to take areas of your personal life and actually build up an interaction diagram for how you accomplish a particular task, and then look at it like it was code. And the reason is you're used to thinking about it this way. And as a developer, you kind of have an outsized advantage compared to other people because of your experience. And so this is a way that you can optimize your general process for dealing with life. So you might as well go ahead and use that advantage for yourself. I've done this recently, just for like the past year or so. I figured out that, things like the overhead of setting up for cooking every night was wasting a ton of time. As a result, I started bulk cooking on Sundays to get rid of the setup overhead. And I literally looked at, hey, what all is involved here? And then how many times I'm having to do that to not batch the work. In a similar vein, I started batching my writing for the podcast rather than doing it in dribs and drabs. Before I would write part of an outline and then I'd come back a few hours later and write another part, go along as I was going. And that didn't really work very well. Now, when I write, I typically take most of Sunday and I just pour everything I've got into it and I get a bunch of stuff done. And that seems to work a whole lot better because I don't have to set up my environment. I don't have to, get my music choices figured out, get my playlist, do all the things I typically do when I work, in dribs and drabs. Instead, I do it all at once and then I do all the work and then walk away from it. The other thing I've done is I've set up stations in the house, in places where I usually write by hand with appropriate writing utensils and paper, instead of having to go find them when I've got to write. And it's this mindset of let me look at my life like a interaction diagram that helps show those things. Because you can see it real easy if you're trained to see it in an interaction diagram. So that's what I've got.
Stand by for Titanfall.
If you have a question or comment for us, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed under Creative Commons. The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up to our email list, be sure and check out the website at completedeveloperpodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with the news about the show. Thanks for listening. See you next time.